Welcome students to Algebra 1, Lesson 34. Today we're going to talk about the greatest common factor. Now if you remember from pre-algebra and maybe even before that, we learned how to find the greatest common factor between two numbers. Let's say 8 and 12. If I can actually write the 2. There we go. When I go too fast, sometimes it skips. So we were able to find our factors through the art of prime factorization, which we just did in the last lesson. We would say, okay, 2 times 2 is 4 times 2 is 8. These are all prime numbers, so this is in prime factorization format. And then we would do 12 the same way. We know that 2 times 6 is 12. 6 is 2 times 3. So this is the prime factorization of 12. And from there we would find our pairs. We have a 2 here and a 2 here. And we would say 2 times 2, the greatest common factor equals 4. That's the number that we could pull out of both of those. And we typically would use greatest common factor when reducing a fraction. We would say 8 divided by 4 is 2, and 12 divided by 4 is 3. And if you pay attention, that's the factors that are left over when you reduce by the greatest common factor. So another way to reduce fractions are simply to write them in their prime factorization. So 8 over 12 would become 2 times 2 times 2, and 2 times 2 times 3 on the bottom, and then you cancel out, and whatever's left is the reduced fraction, just like we had above. So that's one of the main reasons why we find the greatest common factor, is so we can eliminate it. We can reduce by that factor and still have the same value in that fraction, but it becomes a fraction then that is easier to manipulate or multiply or add or whatever it is that we happen to be doing with that fraction. We can also do greatest common factor with terms that are not actual numbers. We can do greatest common factors with variables and exponents. Let's start first with variables. And we know that variables are just letters that replace a value that we don't know yet, or it takes the place of something where we can plug in different values. So if we have two terms here, let's say we have x, m, p, z, y, and we have a, b, x, p, m. We know that when variables are next to each other, they are being multiplied. So by definition, these are all prime factors already. So all we have to do is look for what's in common. So we have an x. So there's our GCF would be, first of all, x, and then we have some p's, p, and then we have m and m. So our greatest common factor for these two terms would be xpm. Let's try another one. We want to find the greatest common factor for these two terms. We have x squared, m cubed, y, z to the fourth, p to, let's say, p squared. And now we're going to do another term, x to the 4, m, y squared, p, and then a squared. So we have to find, let me use my highlighter this time. We have to find those factors that are in common. Well, in order to do that, we're going to have to break some of these down. Like for instance, we have x here, but it's x squared. We don't have an x squared down here. So what we do is we break this down. X squared becomes, or x to the fourth becomes x squared, right? So now we can see that greatest common factor. And right here, we have m to the 3. Well, we can change that to m to the 2 and then put an m over here. So now we have this one and this one that are alike, right? We have y squared here. Well, if we just put another y, we can take that square away, and then this one is the same as this one. So what we're actually doing here, let me rewrite it in a different color. We're actually taking these and we're just breaking them down. X times m times y times z times z times z times z times p times p. We're just taking them down. Let me go backwards for just a moment. Go back to our original terms so you can see what I was doing. All right, this is our original terms. If we take these and we just write above it x times x, m, we have 1 y, we have 4 z's, and 2 p's. Okay, and then we write above this one the same thing. We have 4 x's. Whatever's in here, that's what we write. We have 4 x's, 1 m, 2 y's, 1 p, and 2 a's, right? Now we can identify what they have in common. So we have an x, and an x, and an x, and an x, m and an m, a y and a y, and we have 1p and 1p. That's all we have in common. So our greatest common factor is going to be x, x, m, y, p. And we know that when we have 2 x's here, they all have an exponent of 1. We can rewrite that as x squared m, y, p. That is our greatest common factor because we used x 2 times. We say x 2 times. Okay, but when we write them all out, it makes them a lot easier to identify. Okay, so that's what we want to do for this next problem, for this example 34.1. We want to find the greatest common factor between 2 terms. Let me clear this. And here's our terms. We have 8, this is 34.1. We have 8 z to the 4, m to the 2, and p minus 12 z to the 3, m to the 4, and p squared. So we want to find the greatest common factor of all these. So the easiest thing to do is put all of these in prime factorization. So 2 times 2 times 2, that's 8, times z times z times z times z, 2 m's and 1 p minus 2 times 2 times 3, and then we have times z times z times z, 4 m's, and then 2 p's. All right, so now we identify which ones are common. We have a 2 here and a 2 here. We have a 2 here and a 2 here. We have a z and a z and a z and a z, and we have one more z, okay? Then we have an m and an m and an m and another m. We have a p and a p. So now we just multiply these out. The greatest common factor is going to equal 2 times 2 times z times z times z times m times p. And we can rewrite that as 2 times 2 is 4, z, 1, 2, 3, m, 1, 2, and p. And there's only one p, so we leave it like it is. And this would be our greatest common factor of these terms up here. Okay? We will do more with this later. For now, I just want you to start learning how to pull out what's common between terms in an expression and be able to identify that it's not necessarily about the whole number, but the variable as well has common terms, that there are commonalities between these. And it's a lot like finding like terms, only this time you get to manipulate it a little bit. You get to pull out what's common and show the difference, or actually show what's the same about both of them. And that's all the greatest common factor is. It's showing what is the same about both of the terms. And in this case, this can be pulled from both of the terms. All right, and that would be the answer to 34.1. Let's look at 34.2. Let me clear the page. Now for this one, we're not going to pull it out quite as far. We're going to try to use a little bit of math on this one to help us. And we have a slightly easier number to deal with. There's not quite so many exponents to subtract. So we have 4x squared y cubed z minus 8y squared xz cubed. Okay, so let's try to do this mathematically. So I can tell that 4 is a factor of 8. So I don't have to write it out. I just know that 8 is 2 times 4, and this can be 1 times 4. So 4 is a factor. So I'm going to pull 4 out. I'm going to put my GCF right here. 4 is a factor. Now I'm going to compare the variables. I have an x squared, that's x 2 times, and I have an x 1 time here. So the difference is x 1 time, but I'm not going to write the 1 because we understand that that's its very presence means it's 1 time. All right, let's look at y. We have y 3 times here and 2 times here. So 2 times is what they both have. They have at least 2 times. So let's look at z. We only have a z to the 1 here. We have a z to the 3 here. So z once is used in both of them. This just has some extra. So this is going to be our greatest common factor between these two terms, because we can look and we can get 1x out of both, 2y's out of both, and 1z out of both. If I had made this z squared, it wouldn't be common because there's only z 1 time here. So it's all about the exponent. Okay, look at the exponent and do some subtraction in your head to see what the differences are. All right, and the easiest thing to do is to just find the smallest exponent for that variable, and that is the exponent that you are going to use. All right, and that is the greatest common factor for 34.2. Let's see, I think we have one more. Yes, 34.3. I'm going to change colors just so we can tell where one starts and one stops. And this is a long one, so I'm going to pause and write it. All right, so I've written out our expression. And so now we need to find what's common. Okay, between 16 and 4, we know that 4 is common because 4 times 4 is 16. But when we include this 2, we can't say 4. So it has to be 2 because 2 is the least, or it is the number that is in all of them because we don't have a 4 here. So 2, the greatest common factor here is going to start with a 2. Right? Now we're going to look at the x's. I have x squared, x cubed, and x squared. The smallest exponent for x is x squared. Now let's look at y. The smallest exponent for y is y to the 1. It's always going to be whatever is to the 1. So if you only have y to the 1, you don't even really need to look at these others. You know that it's going to be this one by itself. So you can stop here. Now we have, for p, we have p to the 3. Let's look and see if there's more. We have a p to the 1. So the smallest exponent for the variable p is 1. So we can stop there. And it doesn't matter that this is p to the 15. We can only use one of them because there's only one in the middle term. So the greatest common factor for 34.3 is going to be 2x squared yp, because we can take that out of each individual term. All right, that is all there is to the greatest common factor. It's finding what is common out of each term and putting it all together into one expression or into one term that factors out from the expression. So that's all we have for lesson 34. I will see you in lesson 35.